Hi students, very good morning, welcome back. So in the last section we discussed about the percentage of composition, empirical formula and a molecular formula. Percentage of composition is the mass percentage of an atom of element in a compound. From that we have to calculate the mass of an atom in a compound. The mass of atom in a compound. So today we are going to discuss about the determination of empirical formula, molecular formula. We know that empirical formula is the simplest ratio of atom in a molecule, and the molecular formula is the exact ratio of atom in a compound or a compound of molecule. So the molecular formula and the empirical formula relate as molecular formula is equal to n into empirical formula, where n is the whole number. It is equal to n is equal to molecular mass divided by empirical formula mass. And molecular mass, sometimes the molecular mass is not provided. In such a situation, the vapor density of the compound is given, or vapor density of the molecule is given. So molecular mass is equal to 2 into vapor density. All these things we discussed in the last section. So today we are going to do some problems based on the empirical formula and the molecular formula calculation. Okay, let's start. The first question. Okay, I read the question. You note it into the notebook, and I give you the simple method to determine the empirical formula. The simple method to determine the empirical formula. Okay, the first question. Find the following, from the following percentage of composition of elements of an organic compound, find the molecular formula of the compound. Carbon is equal to 80%, hydrogen is equal to 20%, the molecular mass of the compound is 30. Once again I read the question. From the following percentage of composition of elements of an organic compound, find the molecular formula and the empirical formula. Okay, if we find the empirical formula, we can calculate the molecular formula. The percentage of carbon is 80, percentage of hydrogen is 20, the molecular mass of the compound is 30. These are the information given in the question. So we do the problem. The first question, the percentage of carbon is equal to 80. Percentage of hydrogen is equal to 20. And the molecular mass of the compound is 30. 30 gram. Molar mass is 30 gram. Okay, or simply 30. And there is an easy method to find the empirical formula and the molecular formula. In the textbook, it is given a detailed note, but this is the simple method. The first column we have to make into some columns. The first column is elements. Elements. The elements are carbon and hydrogen. The elements are carbon and hydrogen. Then the second column is percentage of composition. I shortly written composition. Percentage of composition. It is 80%, 20%. The third column is atom mass. What is atom mass? Atomic mass. Okay. Atomic mass of carbon is 12. That of hydrogen is 1. Then the fourth column is percentage of composition divided by atomic mass. That's why we get the number of moles or number of atoms. Okay, percentage of composition means the mass percentage in a compound, or it is related to the mass of the element in a compound. So percentage of composition divided by mass. The fifth column is simplest ratio or simple ratio of atoms, or you can write simple atomic ratio. Simple ratio of atoms, or you can write simple atomic ratio. And the last column is simplest whole number ratio. Whole number ratio. Once again, to calculate the empirical formula of a compound, we make a column method. It is easy. In the textbook, it is a description method. It will take more steps. Okay. So in that, we divided the box into 6 columns. First column elements, second column percentage of composition, third column atomic mass, then fourth column is percentage divided by atomic mass, then fifth column is simple ratio of atoms or simple atomic ratio, then the last one is simplest whole number ratio. Okay, then from the data, carbon 80 percentage, hydrogen 20 percentage. It is 80 gram of carbon in 100 gram of the compound, 20 gram of hydrogen in a 100 gram of compound. That is meaning. An atomic mass of carbon is 12 and the atom hydrogen is 1. Then we have to do the percentage divided by atomic mass. 80 divided by 12. How much you divide? It is 6.666. So I rounded it to 6.67. 3 significant figures or 2 decimal places. Then here 20 divided by 1. What about it is 20.0 or simply 20. Okay. Then simple ratio of atoms. This is the number of moles or number of atoms in a compound. We have to make it into simple ratio. For that, we divide the coefficient. We divide the smallest number with the whole numbers. Okay. ഇതിനകത്തുള്ള small number വെച്ച് എല്ലാത്തിനെ divide ചെയ്യും. അതാണ് meaning. We divide the numbers with the smallest one. Once again, we divide the numbers with the smallest one. Out of these two, 6.67 and 20, which is the smallest one? 6.67. Okay, note പറയാം. നമുക്ക് percentage of atomic mass, percentage of composition divided by atomic mass. ഇത് നമുക്ക് ഒരു number atom ratio, number of moles. ഇത് നമുക്ക് simple ratio യിലേക്ക് കൊണ്ടുവരണം. Simple ratio like number change out of these two values or the values. Okay, maybe 2, 3, 4 like that. Okay, random values smaller number which divide. Okay, smaller number which smaller coefficient which divide. 6.67 divided by 6.67, that is equal to 1. Okay, smaller number 6.67 ആണ്, അത് വെച്ച് അതിനെ ഡിവൈഡ് ചെയ്യണം, ഇതിനെ ഡിവൈഡ് ചെയ്യണം. Then 20.0 divided by 6.67, that is 3. Okay, 6 into 3 18. Then again you multiply, you will get 20 points. Simply divide 20 divided by 6.67. You get 3. It is also in a simple whole number ratio. Just copy it. Sometimes these are also fractions. Okay, maybe 1.5, 2.01 like that. You will see in the next problem. So in such a case, we converted into whole number by multiplying with the suitable numbers. By multiplying with the suitable numbers. So here the number is already whole number. Then empirical formula. Empirical formula of the compounds. How many carbon atoms? C1. How many hydrogen atoms? 3 hydrogen atoms. Okay. Then here itself we can calculate the empirical formula mass. I have shortly written the symbols. Empirical formula. Empirical formula is calculated from the symbol whole number ratio. So carbon atom 1, hydrogen 3. Then from this we have to calculate empirical formula mass. 1 into 12 plus 3 into 1. How much it is? 12 plus 3, 15. Empirical formula mass is equal to 15. Then, what is molecular formula? Molecular formula is N into empirical formula. Okay, you write in your notebook full form. Molecular formula is equal to N into empirical formula. I write only the symbols. Then is equal to, we don't know the N. So N is equal to, N we have to find. What is N? N is molar mass divided by empirical formula mass. Molar mass divided by empirical formula mass. What is the molar mass of the compound? It is given in the question. Molar mass or molecular mass of the compound is 30. So 30 divided by 15. Empirical formula mass we just calculated. So it is 15. Then it is 2. Now N is equal to 2. What is N? N is a whole number. Suppose when you are dividing these molecular mass divided by empirical formula, 1.98 is obtained. You round it into 2. Okay. Suppose the value is 1.98, 1.9, like that you round into whole number. Suppose if the number is 2.01, you round off into 2. Okay, so here it is exactly 2. Then we back into the molecular formula. Molecular formula of the compound is N. What is N? 2. 2 into empirical formula. Empirical formula is C1H3. That is multiplied. C2H6. H6. Okay, this is the molecular formula of the compounds. Are you clear? A very simple method. Make a column. From that, we have to calculate the empirical formula. Okay, these are all the simple steps. Then from the empirical formula is calculated. The N, number of atoms. N, the whole number calculated by molar mass divided by empirical formula mass. Then it is in this case, in this question, 30 divided by 15, that is equal to 2. Molecular formula is equal to N into empirical formula. So molecular formula of the compound is equal to, here N is 2. 2 into empirical formula is C1H3. So 2 into C1H3. Finally, the molecular formula of the compound is C2H3. C2H3. Okay, this is the formula of the ethane. Formula of the ethane. The second problem is taken from the NCERT book. So you just keep the NCERT book while doing the problem. Question is, a compound contains 4.07% of hydrogen, 24.27% carbon, and 71.65% of chlorine. Its molar mass is 98.96 gram. What are its empirical formula and molecular formulas? Once again, I read the question. These are from the NCERT book. Problem 1, 2. A compound contains a 4.07 percentage of hydrogen, 24.27 percentage of carbon, and 71.6765 percentage of chlorine. Its molar mass is 98.96 grams. What are its empirical formula and molecular formulas? Okay, from the question we collect the data. Hydrogen, question number 2, hydrogen, the percentage of hydrogen is 4.07, percentage of carbon is 24.27, and percentage of chlorine is equal to 71.65, and the molar mass of the compound is 98.96 gram. This is the information given in the question. Okay, from that I already give the information. Column method is the simplest one. Okay, in NCERT book there are descriptions. It is a lengthy process. It is the simple process. The elements are hydrogen, carbon, and chlorine. The elements are hydrogen, carbon, and chlorine. Just write the composition. What is the composition? Composition is 4.07. 4.07. Carbon 24.27. Chlorine 71.65. Okay. Then atomic mass of hydrogen 1. That of carbon 12. That of chlorine 35.5. In the textbook it is 35.46 like that. You round off into 35.5. Okay. In the textbook the mass of hydrogen is 1.008. Round off into 1. Percentage of composition divided by atomic mass. Percentage of composition is 4.07. So 4.07 by 1 is equal to 4.07. Next 24.27 divided by 12. Okay, 24.27 divided by 12. It is 2.02. 2.02. Okay, you divide it later. The answer is 2.0. Then here 71.65 divided by 35.5. Atomic mass of chlorine is 35.5. 35.5. Okay, then when you divide this number, the answer is 2.019. So round off into 2.0. Answer is comes 2.019. So round off into 2.0. Then for the simplest atomic ratio. Okay, in the last problem I write simplest ratio of atoms. Then this here I rewrite it simplest atomic ratio. That is enough. Then out of these three values, the smallest value is 2.02. So divide the whole numbers. Divide the whole numbers with a smaller number. So 4.07 by 2.02. It is 2.01. Then 2.02 by 2.02. It is 1. Again 2.02 by 2.02. It is 1. Okay, very clear, very simple. Then the last column is simplest whole number ratio. Simplest whole number ratio. The simplest whole number ratio 2.01. You write 2. Round off into 2. Then 1, 1. From that, we have to write the empirical formula. Empirical formula. For organic compound, we write carbon first. Usually, we write the carbon first. So, carbon 1. Then hydrogen. Hydrogen how much? 2. Chlorine 1. This is empirical formula. From this, we have to calculate empirical formula mass. Empirical formula is obtained from the simplest whole number ratio. From that, we have to calculate the empirical formula mass. How much? Carbon 12, 2 hydrogen. So 2 into 1, 2. Plus chlorine 1, 35.5. How much? 14 plus 35.5 is 49.5. Empirical formula is 49.5. Next is molecular formula is equal to N into empirical formula. N into empirical formula. So next we have to calculate the number of moles. N. Okay. To calculate N, molar mass divided by empirical formula mass. Molar mass or molecular mass divided by empirical formula mass. In the question, molar mass is given how much? 98.96. 98.96. What is the empirical formula mass? 49.5. 49.5. How much? It is 1.999. It converted into whole number because n is a whole number. It is exactly 2. Okay, exactly 2. 98 is the molar, 98.96 is the molar mass from the question. Then 49.5 is the empirical formula mass. It is calculated just now. Then n is equal to 2. Then we come into molecular formula. Molecular formula is n into n is 2. Here n is 2. Then empirical formula. What is the empirical formula of the compound? C1H2Cl1. C1H2Cl1. Multiply it. We get C2H4Cl2. C2H4Cl2. Okay? Yes. Then we do a problem with the vapor density. Okay? This is a problem worked out in the NCERT book. I give it in the simple method. We can also go through the NCERT book. If you feel that one is easy, you follow that method. I think it is a simple method. Okay? So when we move to the problem based on the vapor density. Okay, the third problem is an organic compound contains 61% carbon, 11.8% hydrogen, and the rest of the oxygen. Calculate the empirical formula and molecular formula of the compounds. The vapor density of the compound is 59. This problem is based on vapor density. So once again I read the question. An organic compound contains carbon is equal to 61%, hydrogen is equal to 11.8%, and the rest of oxygen. Calculate the empirical and molecular formulae of the compound. The vapor density of the compound is 59. Okay, let's start the problem. First we collect the data. Okay, I already told you when we get a problem, first we collect the data and analyze it. Then only we have to do or we have to solve the problem. The percentage of carbon, question number 3. The percentage of carbon is equal to 61%, and that of hydrogen is equal to 11.8%, and the rest of oxygen. So what is the percentage of oxygen? 100 minus 61 plus 11.8. Total 100. Carbon is 61, hydrogen is 11.8. So rest of oxygen means the balance amount is oxygen. So 100 minus 61 plus 11.8. 100 minus 61 plus 11.8. How much? It is 27.2. 27.2. That much percentage. Then vapor density. I have shortly written VD. Okay, already I gave the information vapor density VD. So vapor density of the compound is given 59. These things we collected from the question. These are the information given in the question. Then as I what we do the same thing here. We have to do carbon, hydrogen, oxygen. Percentage of composition 61, 11.8, 27.2. Atomic mass of these elements 12, 1, 16. Okay, now we move fast because you are familiar with the two problems. Then a 61 divided by 12, 61 divided by 12, 11.8 by 1, 27.2 by 16. How much it is? It is 5.08. 61. 12 into 5 is 60. Okay, then you divide the value, you will get 5.08. It is 11.8 itself. 11.8 by 1, 11.8 itself. How much it is? This is 1.7. Okay, maybe the value is 1.69 something. I round off into 1.7. Okay, 1.7. Then to get a simple atomic ratio, what we have to do? Divide all these number with the smallest one. Which is the smallest one? This one. 5.08, 11.8. The smallest number is 1.7. So 5.08 divided by 1.7. 11.8 divided by 1.7. 1.7 by 1.7. Okay, 1.7 by 1.7. First you write 1.7 divided by 1.7 is 1. Next we get this is 6.95. 6.95 or 94, no problem. Here we get 2.99. 2.99. Okay, so here only one is whole number 1. Then how we make into simplest ratio? Either we round off into whole number or we multiply with a suitable coefficient. Here it is nearly 3, so just round it off. Round off to 3, 2.93, 6.95, round off. It is 7, 1. Very clear, very simple. Then empirical formula. Empirical formula is equal to C3H7O1. Carbon 3, hydrogen 7, oxygen 1. So that's the empirical formula. What is empirical formula mass? Okay, immediately you calculate the empirical formula mass. That is 8. It is 3 into 12, C3. So 3 into 12, 36. 7 hydrogen, so 7 into 1, 7. Plus 1 oxygen, that is 16. Okay, 16. How much? 36 plus 16. 42. 42 plus 7. Sorry. That is 52. 36 plus 16, 52. Okay. 52 plus 59. 59. Then molecular formula. Okay, you write one by one in the notebook. Here, I write here. You just follow in the downward. N into empirical formula. N into empirical formula. So N is equal to what is N? N is equal to molecular mass divided by empirical formula mass. Empirical formula mass. Molecular mass divided by empirical formula mass. Here there is no molecular mass. The given data is vapor density. So we know that 2 into vapor density is equal to molar mass. Okay, I gave the equation 2 into vapor density is equal to molecular mass of the gaseous compound. Then empirical formula mass. That is 2 into 59. 59, 2 into 59. Then empirical mass is also 59. Empirical formula mass is also 59. Cancel it. We get N is equal to 2. N is equal to 2. Then molecular formula is equal to 2 into empirical formula. Okay, we will write the correct reduce one step. Okay, we skip one step. We apply into this molecular formula N and 2 empirical formula. So 2 into C3H7O O1. C3H7O1. What is the mass? Molecular formula C6. 2 into 3, 6. H14, 2 into 7, 14, 2 into 1, 2. This is the molecular formula of the compounds. Molecular formula of the compounds. Okay, that's about the problem based on empirical formula and the molecular formula. This is a very important problems. You should practice this. Also, I give some problems. I will update in the group. So in the next class, we will discuss about the stoichiometry of a chemical equation. In the 10th standard, you study chemical equation, balancing the chemical equation. So from that we move more information about the balanced chemical equation. Okay, in the next class we will discuss stoichiometry of the chemical equation.